Hello folks, so today I'm going to show you how to calibrate and use a pH probe. Okay, first thing we should note is our pH meter. Notice it has on-off switch, a calibration switch off. We have the glass bulb in there. That's the working electrode. The reference electrode is stored inside. And when we dip this in, the immersion line is somewhere about halfway between here and here. So don't go past here. So as long as we're fully dipping that, we should be fine. So I've freshly made my 3 solutions. Step 1, before I even turn this on, to rinse this off with the water. And then pat that dry with a chem wipe. We don't want to break the bulb, we just want to dry it off. So. Now, I'm going to pour in my first solution to the beaker. Probably only need about 50 mils. Probably not more than that. This is the 6.86. Sometimes this will be enough to calibrate it. You don't even need to use the other one. But we're going to calibrate it with all 3. So I'm going to press on. Dip this in here. Give it a quick stir. Give that a few minutes to, about 30 seconds to stabilize. I think that's probably stabilized. I'm going to hold the calibrate for 5 seconds. Oh, okay. Come on. That's not doing it right. So it should flash 3 times. So that's now calibrated with the 6.86. Gonna rinse that off and dry it off again. Important that you rinse between each samples. So 1, we don't cross-contaminate, and 2, we're starting fresh. So being careful, the bulb should still be intact. I'm going to go ahead and seal that up until I'm ready. So the next one is the 4.0. Stir. Ideally, we might even be using like a stirring bar, but we must be careful when using a stirring bar that we're not allowing it to be whacking the pH probe, and thus potentially breaking the probe. If the glass bulb gets broken, it's not going to work. So I'll give this about 20-30 seconds to stabilize. It seems like it's pretty stable right now. I'll hold the calibrate button again. So this one is auto. It should be auto calibrating itself to 4. Let's see. I'm not. So let's see. Boom. So it's setting whatever that value was for. Give this another rinse. And we'll do it with our last solution, our 9.18. And these are already preset. If we're using a different probe, they might have different pHs, or we might have to physically set it for a given pH. But this one is only 1 pH per thing. Stir. About 20 seconds or so. Then we'll hit the calibrate. Okay. And it's setting that at 9.18. So now it should be more or less calibrated so that each of my 3 solutions, it'll be able to calculate the pH based on each of my 3 solutions, regardless of what I put it in. Let's try the first one. If I put that in the first one, well, it's back to 6.86 or thereabouts. So I think that's pretty good. Pretty good. So dry this off, close it up, turn it off until we need it again. But that is the first part. So, calibration. Once we've calibrated, now it's free. It should stay calibrated for a period of time. We do not necessarily need to calibrate it every day, but if it's under repeated usages or it's been a long time since you last calibrated it, it's a good idea to calibrate again. So we'll continue with our pH measurement now. So this will be a lot easier. We're just going to measure the concentration of various solutions. Now for you'll maybe only measure 1 or 2, probably only 2, and you'll just need to record that measurement. So, since we've already rinsed this off, we'll go ahead and we can just turn this on, give our solution a little, since it's already been rinsed, don't think we need to stir it. I mean, we don't need to rinse it. Put that in there and let that settle. So, the time, as we can see, the ammonium hydroxide, which is essentially ammonia, essentially just another fancy way of saying ammonia, settling around 1004 pH, clearly in the basic scale. We'll see how accurate those numbers are a little bit later. 1004. So I'll rinse this off. try and work with our next solution. Clearly a weak base, but not exactly a very weak base. Let's look at something that should be basic, but maybe not nearly so, as much so. Sodium acetate, which is the conjugate base of a weak acid. Conjugate base of a weak acid, and also in reference 1/10 as dilute. As we see here, this is mildly basic. It's over 7, but at 8.31, this is, or it's stabilizing, 8.23-ish. Let's see if it's still going down. Give it, it's at 30 seconds to stabilize. Jeez. Give it a little stir, let's see. And that little stir seems to have got it down to the proper pH. 7.50. Very, very, very mildly basic. We'll see about some of the other ones in a minute. Dab. So, let's look at, this is 1/10 is dilute, but 0.01 molar ammonium chloride. So right there, we're looking at the conjugate acid of the weak base, ammonium hydroxide. It should be mildly acidic, among other things. About a minute to stabilize. As long as it's bouncing between a set of numbers, it's probably considered stable. But if it's continuing to rise, you may want to give it another stir, give it a little bit more time. It's rising a bit. Be gentle as I stir, try not to break the bulb. Turned off. Okay. We'll label that as 5.47. 5.47. I know it's still creeping up ever so slowly, but clean that off. Now let's do the conjugate, well, the acid for that conjugate base. The ammonia, we did the sodium acetate. Let's look at acetic acid itself. Same concentration. What pH is this dilute weak acid going to give us? your numbers, of course, are always going to be different. It runs on your calibration and among various other factors, but right now it seems, let's see, it's dropped a little bit, 3.56. But let's see, pretty stable at 3.56. The last one we'll do, strong acid. Even though it is rather dilute at 0.01, it is a strong acid. So, see what the pH reads for these. Mils. Probably could use a little bit less. Give it a quick stir. Pretty reasonable. At 0.01, I'm getting a reading of 2.16. To calculate our concentration of hydronium from this, we're just going to take the inverse log of this number. So for HCl, 10 to the negative 2.16 would give us the concentration of hydronium. It should read 0.01, but that value is going to be a little bit lower than 0.01, maybe 0.008 or 0.009. But we could do that for strong acid, strong base, even weak acid, weak base, but those are a little bit more complicated. But that's, last step. Rinse this off, dry it off, and close it up and turn it off. Can't forget the last steps. Hit the off button, and there we go.